Today we will be graphing exponential functions, primarily with shifting. So notice we're going to graph and compare f of x equals 2 to the x power and g of x equals 3 times 2 to the x power. The first thing we're going to do is we are going to create an xy table. We'll do the same, or the first one for f of x. Now, note that we have our xy table already pre-filled out, which is really nice. So we'll start off with 2 to the negative 2 power, which is 1 over 4, 2 to the negative 1 power, which is 1/2, 2 to the 0 power, which is 1, 2 to the first equals 2, and 2 squared, which equals 4. And we will graph these ordered pairs. Okay, so now we're going to use the same x values for g of x, which is 3 times 2 to the x power. So essentially all we're doing is we're taking to the 2 to the x power y value and multiplying it by 3. So for negative 2, we will have 3/4. We'll have 3/2 for negative 1. When x is 0, we will have 3. When x is 1, we will have 6. And when x is 2, we will have 12. And now we're going to graph those ordered pairs. Okay, so it looks like we'll have negative 2 and 3/4. Negative 1 and 1.5. You will have 0.3. Uh, 1/6. And then if you wanted to graph 212, you can, but it is off your grid. Now all we have left to do is to talk about the to talk about g of x equals 3 times 2 to the x power stretches f of x equals 2 to the x power by a factor of 3. And now we're ready to do the next example. If we look here, notice we have f of x equals 1/2 times 3 to the x power. So, and we have g of x equals 3 to the x power. I'm going to do the g of x column first. So 3 to the negative 2 is 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. And I'm going to graph that parent function first. Okay, so note we're going to graph negative 2 and 1/9, negative 1 and 1/3, 0, 1, 1, 3, and 2, 9. Now we can graph our f of x. Note that we're going to have the same x values in our given xy table. So all you're essentially going to do is take your g of x function and multiply all those y values by 1/2. So that means for negative 2, we will have 1 over 18. For negative 1, we will have 1/6. For 1, or 0, we'll have 1/2. For x is 1, we will have 3/2. And when x is 2, we will have 3 squared, 9/2. Okay, so now we're ready to go over and to graph it. Okay, so remember we are going to graph our -2 and 1 over 18. We are going to graph our -1 and 1/6. We will graph our 0, 1/2. We will graph our 1 and 3/2. And we will graph our 2 and our 9/2, which is 4.5. Okay, now as we look here, we can say f of x equals 1/2 times 3 to the x power shrinks g of x equals 3 to the x power by a factor of 1 over 2. In our next example, we're going to graph and compare f of x equals 1/2 to the x power and g of x equals -1/2 x, or -1/2 to the x power. The first thing I would do again is to fill out our xy table. For f of x, 1/2 to the -2 power is 4. 1/2 to the -1 power is 2. 1/2 to the 0 power is 1, 1/2 to the first, and 1/2 squared. We can also fill out our g of x. Notice that it's very similar except there's a negative sign in front. So all we have to do is to negate our y values from the previous table. And now we're ready to graph. I'm going to start off with graphing f of x. So again, for f of x, we have -2, +4. We have -1, +2. We have 0, 1. We have 1, 1/2. And 2, 1/4. Now we're going to graph our g of x, which was all of the y values negated. So now we will have -2, -4. We will have -1, -2, 0, 1, 1, -1/2, and 1, -1/4. So remember, when we do these types of problems, g of x equals -1/2 to the x power is a reflection about the x-axis of f of x equals 1/2 to the x power. If we look at our next example, notice that it says we're going to graph and compare the following 3 functions. I'm going to start off with doing my parent function first, the 1/3 to the x power. 1/3 to the -2 power is 9. 1/3 to the -1 power is 3. 1/3 to the 0 is 1. 1/3 to the first, and 1/3 squared. If you want to do 1/3 cubed, you can, but 1 over 27 is literally on the x-axis. Next thing we're going to do is we're going to do 1/3 to the x plus 1 power. So notice that we'll have 1/3 to the -3 plus 1, which would give me 1/3 to the -2 power, which is still 9. We'll have 1 over 3 to the -2 plus 1, which is 1/3 to the -1, which is just 3. For -1, we'll have 1/3 to the -1 plus 1, which is just going to give us to the 0 power, which is 1. And notice we're going to fill it in as follows. And then I'm not even going to worry about these bottom ones. For x minus 2 as the exponent, notice we'll have 1/3 to the -1 minus 2, which would be 1/3 to the -3, which would be positive 27. 1/3 to the 0 minus 2, which would give us 9. 1/3 to the 1 minus 2 power, which would give us the 3, and 1/3 to the 2 minus 2 power, which would be 0 power, which is 1, and the next one is going to be 3. So now we can actually go and we can graph these. So we're going to graph -2, +9. We're going to graph -1, +3, 0, 1, 1 and 1/3, and 2 and 1/9. Then we're going to graph the next one. Note that we will have in our XY table -2, +3, -1, -3, +9, I forgot that one. We will have -1, 1, 0, 1/3, and then 1, 1/9. And then we'll graph y equals 1/3 to the x minus 2 power. So notice that we will have -1 in 27, which I'm not going to graph. We'll have 0, 9. We will have 1, 3. 2, 0. 2, 0. 2, 1. We will have, and then 3 and 1/3. So note to self that the shifts in this time are horizontal shifts. So notice that f of x equals y equals 1/3 to the x plus 1 power has shifted f of x equals 1/3 to the x power to the left 1. And y equals 1/3 to the x minus 2 power shifted f of x equals 1/3 to the x power to the right 2. Now we're going to graph and compare y equals 2 to the x plus 3, y equals 2 to the x minus 4, and y equals 2 to the x power. So I'm going to start with y equals 2 to the x power, and we have our standard xy table. We're going to say 2 to the -2 power is 1/4, 2 to the -1 is 1/2, 2 to the 0 is 1, 2, and then 4. And let's fill in the rest of our xy tables. We know that we're still going to have 2 to the x power. We're just going to add whatever the y value was from the previous column to the 3. So 1/4 plus 3 is 3 and 1/4. The next one is 3 and 1/2, and then 4, and then 5, and then 7. If we look at 2 to the x minus 4, we're just going to take the first column, our y values for y equals 2 to the x, and subtract 4. So 1/4 minus 4 is -3 3/4. 1/2 minus 4 is -3 1/2. 1 minus 4 is -3, 2 minus 4 is -2, and 4 minus 4 is 0. And now we're going to graph our different values. So I'm going to start off with graphing y equals 2 to the x power. Whoop. Okay, so 2 to the x power, we had -2 and 1/4, -1 and 1/2. We had 0, 1, 1, 2, and 2, 4. And there's our parent function. Now we're going to graph the middle column, y equals 2 to the x plus 3. And notice that we had -2 and 3 and 1/4. And we had -2 and 3 and 1/2. -2 and or 0 and 4. We had 1 and 5. And we had 2 and 7. And now we're going to graph our third function, y equals 2 to the x power minus 4. So notice we had -2 and -3 and 3/4. we had -1 and -3 and 1/2. We had 0, -3. We had 1, -2, and 2, 0. So, note to self, our transformations, this time we had vertical shifts. So y equals 2 to the x plus 3 shifted, y equals 2 to the x up 3, and y equals 2 to the x minus 4 shifted, y equals 2 to the x down 4. Also note to self, what happened to our horizontal asymptote? Well, if I have a vertical shift, your asymptote is going to also shift, whatever that k value is. So for example, this guy, my new horizontal asymptote is the line y equals 3. For this guy, my horizontal asymptote is still y equals -4. And for this guy, my horizontal asymptote is the default, which is y equals 0. In our next example, this is more like what you're going to have to graph in the future. First thing I would do is I would put a box around my parent function. And then I would make an xy table, just like we've done all year. I'm going to use -2, -1, 0, 1, and 2 as my x values. And then I'm going to plug them into the parent function, y equals -1/2 to the x power. So 1/2 to the -2 power is 4 times -1 is -4. 1/2 to the -1 power is 2 times -1, -2. 0 is going to be -1, 1 will be -1/2, and 2 would be -1/4. And so now we're going to plot these points, -2, -4, -1, -2, 0, -1, 1, -1/2, and 2, -1/4. Now, remember this x minus 2 means it's going to go right 2. So we have a right shift of 2. So we'll just move all of the appropriate dots. And then draw our new curve. Okay, so here our domain would be all real numbers. Our range would be from -infinity to 0 with a parenthesis because that's where the asymptote is. And our horizontal asymptote is y equals 0. Take a minute to try the example you tried. Hopefully this is the picture that you do get. So notice you do have an exponential growth model. The parent function is y equals 2 to the x power, shifted left 1 and up 4, meaning our domain is -infinity to infinity, or all real numbers. Our range is from 4 to infinity with the parenthesis because that's where the asymptote is. And our asymptote is y equals 4. You are now ready to try the exponential graphing.